Welcome back to lecture 4, how to calculate the loads. In this lecture, we are going to learn how to obtain the load for electric devices. As you know, some devices work on single phase and some on three phase. We will start with single phase, then we'll jump to three phase. We are interested in power law, which is equal P equal I times V times PF. P is the power in watt, I is the current in ampere, V is the voltage in volt, while PF is the power factor, which ranges between 0.85 and 1. We will consider it 1. Assume we have an ideal system, so that we assume power factor is equal to 1. Therefore, P is equal I times V times 1, which is I times V. Moreover, we will consider single phase voltage is equal to 220 volt. Is that clear? Okay, remember, P is the power consumed by the machine, and it's always written in the machine, so that the current is left as unknown. So our objective is to calculate the value of current in order to know the suitable circuit breaker for that machine. Don't be panic. It's an easy lesson, but we might spend more than 20 minutes, I guess. No problem, we are ready. So yeah, let's get started. Example number 1. Assume you have an AC which consumes 2.5 kilowatts in 220 volt. What's the required circuit breaker for this AC? Solution. Okay, from the given, we can understand that this AC works on single phase. Now let's use the power law to obtain the current, taking in consideration the power factor is equal to 1. Yeah, we know that P is equal I times V. Therefore, I is equal P over V. Let's subtract the values in the formula. We will get I is equal 2.5 times 1000 over 220 volt, which is equal 11.36 ampere. To be in a safe side, increase it by 25%. So I becomes 11.36 times 1.25, which is equal 14.2 ampere. Therefore, we will choose the nearest circuit breaker, which is 16 ampere. Yeah, guys, we choose 16 ampere because you will not find in the market a circuit breaker with value of 14 ampere. Instead, the value of circuit breakers are standard, like 16 ampere, 20 ampere, 25 ampere, 32, 40, and so on. In this exercise, we got 14.2 ampere. As I said, there's no in the market a value of 14, so we choose 16 ampere. Pay attention that we multiply by 1000 because we want to convert from kilowatt to watt. So simple, so easy. So let's move. Let's solve the same example with faster method. Okay, let's jump to solution. I is equal 2.5 times 1000 over 220. Now look carefully. The 1000 over 220 is constant at it, and it will exist in all single-phase calculations. So calculate this ratio, then take the result and multiply it by the value of kilowatt. Therefore, the constant is equal 1000 over 220 volt, which is equal 4.5. As a result, I becomes equal 2.5 times K, 2.5 times 4.5 equal 11.25 ampere. Approximately the same result as before. Also, don't forget to add 25%, then choose the nearest circuit breaker. We conclude that for single phase, to obtain the current, multiply the value of kilowatt by 4.5. That's it. So simple, so easy. Example 2, method 1. Assume you have a boiler which consumes 1.5 kilowatt power in 220 volt. So what's the required circuit breaker for this boiler? Okay, from the given we can understand this boiler works on single phase voltage, which is 220 volt. Now let's apply the power law to obtain the current. P is equal I times V. Therefore, I is equal P over V. Drag the values to the formula. I is equal 1.5 times 1000 over 220. The answer is 6.8 ampere. Finally, add 25% and choose the nearest circuit breaker, which is 10 ampere. Again, I repeat, we choose 10 ampere. We choose 10 ampere circuit breaker because there is no circuit breaker 8.5 ampere. Also, we've multiplied by 1000 to convert from kilowatt to watt. Example 2, method 2. Okay, we know that I is equal 1.5 times 1000 over 220. You can observe that the ratio 1000 over 220 exists in all single-phase equipment. So calculate the ratio, then take the result and multiply it by the value of kilowatt. I is equal 1.5 times 4.5, which is 6.75 ampere, approximately the same as before, and you know the rest of the procedures. We conclude that to determine the current in single phase, multiply the load in kilowatt by 4.5. So simple, so easy. Okay, example 3, method 1. Assume you have a vacuum cleaner which consumes 700 watt and 220 volt. So what's the required circuit breaker for this machine? Please pay attention that the given power is in watt already. It's in watt already, so no need to multiply it by 1000. Okay, let's solve the question. Direct application. I is equal P over V. 700 over 220 volt equal 3.18 ampere. Now add 25% and choose the nearest circuit breaker, which will be 5 ampere. Hint, I didn't multiply by 1000 because the load is already in watt. Okay? Example 3, method 2. Okay, here in this case, the load is already in watts, so don't multiply 700 by 4.5 directly, because first you must convert the load from watt to kilowatt in order to be able to use the method 2. So yeah, to convert from watt to kilowatt, you have to divide by 1000 as shown. 700 over 1000, you will get 0.7 kilowatt. Now you can apply the method and multiply 4.5 times 0.7 to get the result. Okay, let's move to three-phase. In a three-phase, the power law is equal to radical 3 times V3 phase times I times PF. Neglect the power factor because we assume it is equal to 1. So P3 phase becomes radical 3 times V3 phase times I. Radical 3 is constant and the voltage in three phase is equal to 380 volts. As a result, the power in three phase is equal to radical 3 times 380 times I. If you want to analyze, here you go. We know that three-phase voltage is equal to radical 3 times single-phase voltage, which means 380 is equal to radical 3 times 220 volt. Okay, replace it in the formula. You get P3 phase is equal to radical 3 times 220 times I, which will be 3 times 220 times I. Don't be confused. Choose anyone you want. Okay, let's continue. Example 1, method 1. Assume you have an AC consumes 2.5 kilowatt and 380 volt. What's the required circuit breaker for this AC? Solution. Clearly, this AC works on three-phase since the voltage is 380 volt. In this case, the power is equal to I times V times radical 3. Therefore, I is equal P over radical 3 times V. Yeah, let's drag our values in the formula. We get I is equal 2.5 times 1000 over radical 3 times 380. The answer is 3.8 ampere. Now the same procedures as we did before, increasing 25% and choosing the nearest circuit breaker. Pay attention that the voltage in three-phase is 380 volt instead of 220 volt. And you have to multiply it by radical 3 when you are using the power law. The same example using method 2. Look here, after dragging our values, the ratio 1000 over 380 times radical 3 will exist in all three-phase equipment. So calculate the ratio, then take the result and multiply it by the value of kilowatt. The ratio is equal to 1000 over 380 times radical 3. The answer is 1.52. Now you can obtain the current. I is equal to 2.5 times 1.52. The answer is 3.8. And you know what to do in next steps. Okay, we conclude that in three-phase to obtain the current, multiply the load in kilowatt by 1.52. That's it. Example number 2, method 1. Assume you have a boiler consumes 1.5 kilowatt and 380 volt. What's the required circuit breaker for this boiler? Well, let's apply the power law. P is equal I times V times radical 3. Therefore, I is equal P over V times radical 3. Okay, direct application, as you can see. There's nothing new. The same example using method 2. I think you've become familiar with this. So yeah, immediately multiply multiply the load by 1.52, then follow the same procedures. That's it. Quick questions. Let's review what we've learned by answering these questions. Question 1. A motor with the rating voltage 380 volt and consumes 3.7 kilowatt. What's the required current or circuit breaker for this equipment? Okay, since it works on a three-phase, so I is equal 3.7 times 1.52, which is 5.6 ampere. Question 2. A boiler with rating voltage 220 volt and consumes 2.8 kilowatt. What's the required current or circuit breaker for this equipment? Since it works on single phase, the current will be equal. I is equal 2.8 times 4.5, which is equal 12.6 ampere. And if you want, you can add or increase by 25%. Reverse questions. In these questions, you are requested to obtain the power instead of the current. Question 1. Assume you have a single-phase circuit breaker with rating 16 ampere. How much the total power can this breaker handle? My friend, listen carefully. Now the current is known, but the power is unknown. Let's apply method 2. We know that for single phase to obtain the current, we multiply the kilowatt by 4.5. So kilowatt is equal I over 4.5, which is equal 16 over 4.5. The answer is 3.5 kilowatt, which means this breaker is suitable for a device consumes 3.5 kilowatt. Is that clear? Okay, let's see question 2. Assume you have a three-phase circuit breaker with rating value of 20 ampere. How many kilowatts can this breaker handle? Okay, we apply method 2 for three-phase. We get P is equal I over 1.52, which is equal 20 over 1.52. The result is 13.15 kilowatt, which means if you have a three-phase machine consumes 13 kilowatt, the suitable circuit breaker is 20 ampere. That's it. As you know, this power socket is called 13 ampere single power socket with rating voltage of 220 volt, which means it's a single phase power socket. Approximately, this power socket can handle up to 2.8 kilowatt. As shown in this picture, this is called an industrial power socket with 16 ampere and 380 volt, which means it's for three-phase. However, this power socket approximately can handle up to 10.52 kilowatt. Conclusion. Okay, everything is clear. You can read it alone. Well, this was everything for this lecture. I hope it was clear enough for you. If you have any question, of course, you can contact me. See you in the next lecture. Good luck.